So the reason why you're saying this is because you can only have one and you can't have both, right? You can't have a consistent and available system. So
Yes.
what is the reason for that distributed environment? So if you have a distributed environment, you can only follow this principle of cap theory. Okay, so the thing is, right? So I'm going to give you like feedback. Now, the thing is, it seems that you have not seen this problem before, right?
Yeah, yeah, right.
So yeah, I mean that's expected. Like so, even when I don't know a problem, I won't know how to do it. But I'll give you a template to follow.
Okay, let's start. Sales rank. Um, Amazon allow users to view the past week's most popular products by category. Okay, based on purchase from other customers. Okay, design a feature like Amazon sales rank by category. Okay, just give me 1 minute
Sure,
to
sure.
just think about it. So let's define the requirements first.
Okay.
Okay, so we need to design the category
Hmm.
ranking for products. So um, so in a particular category there are bunch of products and based on the purchase from most popular products. So in that category, uh, the particular products which are customers are giving preferences, higher preferences, that we can show the ranking, show that products on the top level into that category.
Okay.
We have category then. So first, products, category and products listing, um, products, and in category. In the main functional requirement we can keep this thing, and if time permits we can go for the also search for a searching for a product. But okay, and
Okay.
in the non-functional requirement we can say this is highly available.
Hmm.
Say eventual consistency for listing of products. We can have this. Okay, so is that a requirement sufficient, or we can add any other into the scoping?
Yep, this is good. So regarding the non-functional requirements, I think that you can assume one more non-functional requirement, like since you're choosing between availability and consistency, there must be a third one. So do you know what that is? So you're telling me that it's going to be highly available and eventually consistent.
Yeah.
So the reason why you're saying this is because you can only have one and you can't have both, right? You can't have a consistent and available system. So
Yes.
what is the reason for that?
Not sure. I need to
Yeah, no problem.
search
So
on.
the thing is the answer. So what I was expecting is simply scalability. So that's the third requirement. So the
Okay.
reason why you've written high availability is because there is something called cap theorem. Do you know what cap theorem
Yeah.
is?
Yeah. Okay.
Yeah, so that's what I like. So the thing is, when you mentioned you want availability and you said eventual consistency, I just asked like what was the third one? Because usually in an interview they will ask why are you choosing between these two? So the question will be like why not all three? And the reason is you want it to be in a distributed environment. So if you have a distributed environment, you can only follow this principle of cap theorem. So cap theorem states that you can either have high availability and scalability, or you have to have high consistency and scalability. So that's it. So just like you needed to just simply state it, that's it. But everything else is fine. Yeah.
Yeah. Okay. Okay.
Yep, this looks good. Yeah.
Okay. Um, Fine. Now we move towards estimation.
Hmm.
Now, how much scale that we are looking for approximately?
Okay,
Users,
so
you can say.
let's say that there are about 100 million products in the website,
Okay.
and let's say there are about 1 billion transactions per month.
Okay.
So just one thing, it's 100 million here. No, like so, I just click 10. Yep, sounds good.
First, we try to estimate the data model. So we have category, um, ID, uh, category name, and uh, other category metadata. Okay. Products, we have product ID, product name, um, then um, product category, which has um, product ID and category ID. We can have here approximately 100 uh, bytes for each product, for each category, and uh, in category we can have approximate, if we can estimate 100 categories, then we have 100 uh, uh, 10 to um 10 raised to 3, um 10 raised to 3 overall uh, bytes. Means we can have approximately 10 is 10 MB. So that is not that much. If you can go for the products, then products would have more data. uh, so for the product we can say approximately one product and other metadata, if we can consider approximately 300, then same for 100 million, we can have uh, uh, 3 into uh, uh, 10 raised to 6 9, so approximately it comes uh, three uh, uh, so 3 GB 3 GB of products we are expecting. Okay, and for category also, product category mapping also, that not go beyond that much. So we can here we can expect the some transactional DB. Transactional DB can go for MySQL because this data is not that much of large. And uh, okay, yeah. uh, so that sounds good, or we need to.
Yeah, that sounds good. Just one small mistake in the calculation, it's fine. Like, so when you're doing 10 to 10 into 10 to the power 3, that's 10 to the power 4. So this would be, I think, 10 kilobytes, right? It's not 10 megabytes, I think,
Oh,
because mega is 10 to the power 6. Also, here, you said 300 into 100
got that, yeah.
into 10 to the power 9. It's 10 to the power 10, I think. So it's 30 GB.
Oh, okay, okay.
Yeah. Yeah, no problem. I mean, anyways, it's the same, but yeah, like you can just do approximate calculation.
Yeah, yeah,
So it's
sure.
fine.
Okay.
Yeah. Yeah, looks
uh,
good.
okay, so now we go for the uh, design of the product.
Mhm.
So even here I think I missed something like the rank most popular product. So we can have some into the same product, or a product DB, or yeah, we can have into the product DB as popularity rank. So it's only the ranking that we can add if customers are searching this product, clicking or viewing this product more time, then we just add +1 to this ranking, so that
Okay.
that count case get increased. uh,
Yeah.
so this is popularity rank. So okay. um, Okay. So I guess the question is on the only the most popular product category. So we deep dive into this popularity rank itself. I feel for this, first we can maintain the one cache over there, and then we update that data into the main DB. Okay, and for here we can have some updating, and uh, for we will keep some limitation as for the first page as 100 popular products, and beyond that we will just remove that, so we can implement have uh, least LRU over here, least recently used. So we
Yep.
can remove the least recently product from that cache, and then we update our primary DB. So depends on this, we just list down the first top 100 products over here. So uh, to maintain this, we can have a first hash of that product, hash map, and into hash map we can have the product name, or we can have that instead of product name, product ID, which is getting most once the product is click that product ID, we will update with the rank. So rank is just a rank count. So we can maintain this into the hash map, and depends on LRU we will remove the least recently, and that hash map is get updated, and this 100 top products we can show to the and this will get uh, cache will get updated to DB, and the search query will fetch that the top 100 products.
Yep.
So
Okay.
for define detailing wise, so if you can see here, client, you can have load balancer over here, and these are the API servers. And our database. So in between we have our caching layer here. So this product we serve through cache and from the DB. And for adding and updating, so we will have the admin, so that uh, product and categories will get added by this admin. uh, uh, to directly this to cache table, so we can use a write through cache mechanism.
Mm-hmm. Can you tell me why you're using write through cache?
uh, uh, Once we know we are our read, say, this system is read heavy. So
Mm-hmm.
once we our client is directly reading from the cache, and uh, once um, yeah, actually, write instead of write through cache, we will write into DB, and in the async manner we write into the cache, because it's as we discuss, it's eventual consistent, uh, right? So
Yep.
this would be fine instead of write, because we'll miss the if the cache gets lost, then uh, we'll miss the actual data. So
Yep.
yeah, this looks fine. um, and I guess um, yeah, sales rank uh, can be directly fetched from the DB now. uh, okay, for sales ranking, here this the a normal serving process. Will have here another our uh, ranking service ranking service, which update the data, uh, update the this we'll have another caching layer here for uh, maintaining our uh, the this thing, 100 top product cache layer, and this will update to caching, and uh, that most recent products will get updated to directly to DB. And here, from here, our read queries are getting served, and from here our update products, ranking products are getting served from here.
Mm-hmm.
uh, yeah, yeah, that's cool. That's fine. Do you think that's fine, or we can add something?
Yeah, I think it's fine. Yeah, I think this is okay for now. Okay, so the thing is, right? So I'm going to give you like feedback. Now,
Yeah.
the thing is, it seems that you have not seen this problem before, right?
Yeah. Yeah. Right.
So yeah, I mean that's expected. Like so, even when I don't know a problem, I won't know how to do it. But I'll give you a template to follow. This
Okay.
is based on some interview experiences. So first thing is when you're given a problem like this, it's good that you first went to requirement. This is called as functional requirement, and this is called as non-functional requirement. So when you go to the functional requirement, there are something called as core functional requirements. So the difficult thing is to identify what the core functionality is, right? So in this case, it says that Amazon allows users to view past the week's most popular category, design a feature like Amazon Sales Rank. So now we know a couple of information. So let's write that down. So the first thing I know is that okay, so we're talking about Amazon. I've used Amazon, so I know what they're talking about. So, okay, let me just go ahead and do this. Okay, so there's something called as past week's most viewed category. So my goal is to be able to design that page, right? So I need to think about this. How am I supposed to design it? Well, I think that the first thing is there's probably going to be a ranking system. And what this ranking system will do is it's going to take some data, right? And then using this data, it's going to, it's going to rank. So, it uses data, then it does some processing. We all know that machine learning, something exists, some processing, but we don't care about that. It's not ML interview. So using all of these things, it would be able to rank, the products. That's great. Third thing is, once it ranks the products as a user, I should be able to view it. So I should view this product. So that's it. That's all there is, right? So in terms of core functionality, you just need to build a ranking system and you need to build a user viewing system. So that's it. So you've done that pretty well. So you said that the category ranking for products exists, category and products, listing the products in the category. You don't really need searching products, which is good. You mentioned that this is like probably if time permits. So that's great too. Coming to the non-functional requirements, this was good, just that the cap theorem has to be remembered. Apart from this, there's also some other stuff that you can mention. When you are designing a huge system like Amazon, let's say you're working on it and suddenly it stops working, right? That's not good. System is like pretty bad. So that's what we call as fault tolerance, right? So this is like you have to build a system where it's supposed to be good no matter what. So that's what I would add additionally. Just some small things, not like a big deal. So that's great. Um, Now coming to the estimations, this was fine. You did like a lot of good calculations here. I don't know about other interviews, but for me, right, I would not write the data model right here itself because the thing is, initially you want to do an estimation. It's good that you were able to identify what data model you have to use, but in an interview, I wouldn't know how to do that. So I would do estimation first, then I would go to high level design, which is here. Then I would write data model here, based on what I need. But yeah, that's the only thing. So apart from that, everything is fine. You wrote the high level diagram, which is great. Sometimes you can use color, so something like this to differentiate between the types. Like for example, load balancer can be different color. API server. It's only so that it looks slightly, like easier to
Yeah.
grasp.
Okay. Okay.
Yeah. One more thing is that we ran out of time right now, but usually after this, what you would do is, it looks good for me, but maybe someone would say, hey, this system has a single point of failure, right? So if this load balancer crashes, what will happen? Uh, so you would have to build redundancy to the system. It's very easy. What you would do is you would simply say, I'll create something like this. So basically, you're having multiple load balancers.
Okay. Okay.
Yeah. That's what redundancy into the system is. Also, I think that you mentioned quite a few caching mechanisms. That's good. I don't know a lot of the caching mechanisms, but in my opinion, right, if the interviewer does not ask, then you don't have to tell. If he goes deep, then you can say, because initially you said right through cache. That gives me an opportunity to ask more questions. And if you're not able to answer those questions, then the interview is over.
Okay. Okay.
So it's good that you know it. I don't know a lot of these things, but yeah, it's better to not say if the interviewer doesn't ask.
Okay, got that. Yeah,
Yeah, but it was good overall. Yeah, pretty good for a problem that you have not seen.
yeah, yeah. Great. Thanks for this detailed feedback. Yeah.
Sure.